Hello everyone, I am Veena Gandhi, Assistant Professor from Department of BCA Science. I welcome you in Advanced C Programming course. Today in this video you will learn main topic Arrays in C part 1. A topic covered in this video are what do you mean by array, types of array, then one-dimensional array declaration and initialization, how to access the one-dimensional array elements, size of the array and finding the address of one-dimensional array elements, how to pass arrays to functions, and C programs on concept of the arrays, an assignment on above topic. Before looking into definition of array, let us see first why we require array or what is the need of array. Suppose for example, if we want to store salary of 100 employees, then in that case we have to define 100 variables in a program, like salary 1, salary 2, salary 2, salary 3 up to salary 100, and we have to apply the operation on these 100 variables. It is very tedious and time consuming as very difficult to keep track of 100 variables. In this type of situation, C language provides us data structure called as array, which allows us grouping of data items of similar type under a single name. So array can be defined as collection of data items of same type which are stored in consecutive memory locations and referred by a common name. Now it is a linear and homogeneous data structure. Homogeneous means all the elements are of same type of data are stored. Linear structure stores all the its elements in sequential manner in a memory. The type of the elements may be any valid type like int, float, char, structure, pointer, etc. The elements of the array share the single variable name, but each element has a different index number known as subscript. That we can access the elements of an array using this index or subscript. So array is also called as subscripted variable. Now this each subscript must be expressed as a positive integer or non-negative integer. The value of each subscript can be expressed as an integer value, integer constant, or integer variable, or it can be integer expression. A general syntax for declaring array is data type first, then array name, then in square bracket you can mention the dimension or size 1, size 2, size n, where size 1, size 2, size n specify the dimension of the array. Data type can be anything, int, float, char, structure, pointer, etc. The array name should be valid identifier name. For example, int age 100 means age stores the 100 elements of type integer. There is a one dimension here, so it's a one dimension array. One subscript is here, so one dimension here. Here char name 20 and 80. 20 and 80 are two subscripts, so it is two-dimensional array of char type. Now volume is having three subscript 80, 20, 40. So it is three-dimensional array of float type. Types of array. Array can be a one-dimensional array, it can be a two-dimensional array, or it can be a multi-dimensional array. One-dimensional array having one subscript, two-dimensional array having two subscript, and multi-dimensional array having more than two subscripts. In this video, we will focus on one-dimension array. The one-dimensional array has one subscript. Now this array can be represented as a row or column, one row or one column. The one-dimensional arrays are also known as vectors. You can see here, we can represent the array as a one row or here one column. One dimension array declaration. A one dimension can be declared as first data type specifier, then array name, and square brackets single subscript, that is size here. It allocates the memory for specified size elements. A subscript of the first element is 0 and subscript of the last element is size -1. Now the size of subscript must be positive integer constant. For example, int roll number of 100. It defines an array of 100 integers. Char str of 80. It defines an array of 80 characters. When one-dimensional array is declared, the compiler will allocate a memory to store entire array. Now in C language, the subscript always start with 0 and increment by 1. So if I say y of 5, so y of 5 will be the sixth element because subscript always start from 0. It is sometimes convenient to define an array size in terms of symbolic constant rather than real quantity. For example, hash defines size of 80, and if I declare an array string of type char and square bracket, instead of mentioning positive computer, I can mention the symbolic constant here size. So in future, if I want to modify the array size, I can only change the value of size symbolic constant. Our next topic is how to initialize a one-dimension array. There are various ways to initialize the one-dimension array. The first method, compile time initialization, means arrays can be initialized at the time of declaration when we know their initial values in advance. For example, we declare array here a int type and having size 5 and initialize with the values in curly braces. We are specifying here 5 values 10, 15, 1, 3, 20. So we are storing the initial values in the array at the time of declaration. You can see in a figure, values are stored in a memory in continuous sequential manner. First element, first number 10 stored at location 1000 location, and subscript starts from 0. So a of 0 here. Next number stored at a of 1. Here next number is stored at 1002 because for each element in the array memory is allocated. So first element stored at 1000, second int type is here. So it requires 2 bytes under 16-bit compiler. So next number will be stored at 1002. Next number will be stored at 1004. Then 6. Then 8 like that. So an array index start from 0, 1, 2 till size minus 1, that is size is here 5. So 5 minus 1, 4. Next topic is partial array initialization. If the number of values to be initialized is less than the size of the array, then it is known as partial array initialization. For example, here in an array a of 5 of type integer, we provide only 2 values 10, 15. So this is known as partial array initialization. Means size of the number of the values to be initialized are less than the size of the array. Now in this case, remaining elements will be automatically replaced by initialized with the 0 here. You can see in this figure, first values are 10, 15 and remaining values are initialized with the 0 by the compiler. So a of 2 is 0, a of 3 is 0, a of 4 is 0. Now in case of non-numeric array, this character array, it will be initialized by the space. We can also initialize the array without specifying the size of the array. For example, here suppose B array of character type, and here I have not mentioned the size in square bracket and initialize with the values computer. Computer is it is character array. Now in this case, compiler will automatically find the size of the array by counting the initial values. So here values are total 8 values. So compiler will allocate the size of the B array as 8 characters. So you can see in this figure, values are stored continuously computer starting from location 1000. Index start from B of 0 here and stored continuously here. So next element will be stored at 1 element because character type requires 1 byte. So next number will be 2, 3, 4, 5, 6 like that. The array index starts from B of 0 and end with B of 7. Size is 8, so last index will be size minus 1, that is 7. Array also initialized with a string. Consider here example char B and initialize with the string computer. Here I initialize the B array with a string in double quotes computer. Even though string computer contains 8 characters, but string always end with what? Null character or null byte. That's why we require one byte more to store the null character. So compiler will allocate the size 9 for the B array instead of 8. So it is same as char B of 9 equal to computer. 1 byte is more for the null byte. So when you initialize the string, when you initialize the array with the string, in that case, array size should be more, 1 character more than the number of characters in the string. So you can see in this figure, string computer is stored like this, computer, and at the end, null byte is stored here. So array index start from 0 and end with what? B of 8. Next topic is how to access the array elements. Now we can access the array elements by using the array name followed by in square bracket subscript by specifying the subscript. Suppose we declare the array here int marks and size is 5. Initialize with the value 52911. So array index starts from 0 and last element will be stored at what? At the fourth element, means size minus 1, that is fourth. So we can access the array of marks by using the subscript like this. Marks of 0 means this element will point to the first element 5. Marks of 1 is the second element, it will point to the 2. Marks of 2 will point to the third element, it is 9. So we can access the array elements by using the array name in square bracket. We can specify the subscript that specify the element to be accessed. So array subscript always start from 0 and end with size minus 1. Let us see simple program on arrays. Here I am using here Turbo C++ compiler. You can use online this. Let us see simple C program to accept the n values from the user and store them in array and display the what? Same values. So first include the header file here, stdio.h file here. After that I am including config.h file here to use the function clear screen. So here I define the integer array values having size 50. An n variable, I want to store how many elements we want to store. So for that we require n variable and I variable for the for loop. First I first use here clear screen function to clear the screen. Printf how many numbers you want to store in the array. Then scanf %d %n. After that we want to accept the n numbers. So the numbers for I equal to 0, I less than n, I plus plus or plus plus I. You can use any thing, I plus plus or plus plus I. So array index starts from 0. So we are starting I equal to 0. Scanf %d % values of I. So values followed by subscript in square bracket and I is the subscript. After that we want to display same integers. So displaying integers. Again we require for loop for I equal to 0, I less than n, I plus plus. Printf \n %d values of I. So we are storing and we are retrieving the elements and displaying on the screen. After that return 0, get ch and return 0. Let's save this program and compile. Statement missing is error. So after the printf there is no semicolon, so it will give error. How many numbers you want to store? Suppose I want to store 5 numbers, and numbers are 10, 20, 30, displaying the integers 50. Our next topic is how to assign the values to array elements. Now, values can be assigned to individual elements of the array by using the assignment operator. Syntax for that is array name in square bracket subscript or index equal to value. For example, a of 0 equal to 10, a of 4 equal to 100. Now we can't copy all the elements of the array into other array by simply assigning it to the what other array. For example, we have two arrays, a of 5 and b of 5. And suppose a of 5 contains 1, 2, 3, 4, 5, and we want to assign these values to b array. So we cannot write like this, b equal to a. It will give error. If we want to copy the a element into b, we have to write a for loop for that. So we can copy element by element. For I equal to 0, I less than 5, and b of I equal to a of I. This a of 0 will be copied into b of 0, a of 1 then I plus plus, then ai will be 1, so a of 1 will be copied into b of 1 like this. So we cannot assign b equal to a. It is invalid operation. Next topic, how to find the size of the array and address of the any array element. So to find the size of the array in bytes, we require size of the array and size of the data type. So size of the array in bytes equal to size of the array multiplied by the size of the data type. For example, int a of 40 means a is an array having size 40 of integer type. So size of the a array will be 40 subscript 40 into size of the int. Under 16-bit compiler it is 2 bytes. So 40 into 2, 80 bytes. Next is char b of 50. So b is a character array and char array requires 1 byte. Char array requires 1 byte. So array size of the b array will be 50 into 1, 50 bytes. Then double salary of 20. So double requires 8 bytes and the subscript is here 20. Size is 20 here. 20 into 8, 160 bytes. Now to find the address of any array element, we require base address and then we require subscript and size of the data type. So size of the any array element in the array equal to base address plus subscript into size of the data type. For example, if the scores is the int array of having size 7 and scores array address of the first element is stored at 1000 location. You can see in this array here, base address is 1000, means first element score of 0 is stored at 1000 location. And if you want to find the address of the score of 5, so you can write the formula like this: base address 1000 plus 5 is what subscript here. Okay, 5 into size of the int array, it's 2. So 5 into 2, 10. So 1010 is the what address of the what score of 5. You can see here in this figure, score of 5 is stored at the address 1010. So to find the address of any element, we require base address plus subscript into size of the data type. Let us see another program to find the maximum of numbers, maximum of n numbers. So first, include the header file stdio.h, then conio.io.h for clear screen. In the main function, define the variables n, I, max, and then num of 100 elements, num array of 100 elements. Then clear screen here. Then ask first how many numbers you want to store. So scanf %d %n. Then in the for loop you accept the n numbers. So for I equal to 0, I less than n, I plus plus. That in that loop you print integer number. So I want to print integer number of 1, integer number 2. So I plus 1 is first element, second element, like that. Then scanf %d %num of I. Now for finding the largest number, first we store the num of 0 in max variable. Then compare the next elements from means num of 1 to till last element. We compare the elements. the for loop. So for I equal to 1, I less than n, I plus plus. Inside the for loop, if max is less than num of I. If it is true, then max will be num of I. So till the end of the loop, till the end of the array, we will check the every element. After that, print the largest element equal to max. Then get ch. Now run this program. So enter how many elements you want to store. Suppose 5 elements. Elements are like this: 45 minus 6, 34, 93, and largest element is 90. This way we can use the array for storing and retrieving the elements. For finding maximum numbers, you can use array in many applications. Next topic is array and functions. There are two methods to pass array to function. First method is passing array element by element, and second method is passing an entire array to function. Now in first method, array elements are passed one by one to function. So only the function gets access of only one element at a time. So any changes made into the function cannot affect the original array value. This is known as call by value method of parameter passing. Now when we pass entire array to function, in that case we send the name of the array to function, and name of the array refers to the base address or starting address of the array in a memory. The name of the array is a constant pointer. It cannot be changed. Now when function gets access of the original array, then any changes made inside the function also reflected into the original array. So when we pass entire array to function, it is known as call by reference parameter passing method. Let us see how to pass the array elements to function. Now in first method, we pass the array element by element to function. In this program, first include the header file stdio.h file, then include the file conio.h. Then I have defined here a function void display and passing two values here, function h1 and h2, and printing that value h1 and h2, and close the function display. Now in main function, I have declared the array h array, initialized with the value 2, 8, 4, 12. Okay, so here I have not specified array size, so compiler will allocate 4 size for the array. Then clear screen. It call the function display with the values h array of 1 and h array of 2. So we are passing the element, not complete array but element, h array of 1 and h array of 2. So it will print the values 8 and 4. H array of 0 is 2, h array of 1 is 8, and h array of 2 is 4. So after running this program, you can see here output 8 and 4. Now next program, we can pass the entire array to function. So here, first include the header file stdio.h. Now again, second, include the file conio.h for clear screen function. Then declare the function calculate sum, which accept the entire array float num. In main function, initialize the num with the values, then call the function clear screen, and after that call the function calculate sum. Here I am passing now name of the array, so I am passing here entire array here. After that, control will come to the calculate sum array. So here num will get the what original array here, and then sum inside the function sum equal to 0.0 I. In the for loop we are calculating sum of every element. So for I equal to 0, I less than 6, sum equal to sum plus num of I in I plus plus. After that I am returning the what sum. This sum will collected into the result variable, and then after that print the result. So here we are passing the entire array, so called by reference method. When we pass the element array, when we pass the array element by element, it is called by value. Now run the program. You can get here result sum of the all elements here. This way we can pass the array to function. Let us see assignment. Short questions. Define an array. Second question, what is the address of the element s of 7 if the base address of an array is 2000? Next, what are the types of an array? Long question, how to declare and initialize the one-dimensional array. Second, how to pass the array to function. Now in next video we will see two-dimensional array and multi-dimensional array. I hope you will like this video and you must understood the concept in this video. If you like this video, please share and subscribe the college channel. Thank you for watching.